Hi, everybody. We are starting Unit 2 with doing a review of atoms and the periodic table, or if you don't know these, an introduction to the atoms in the periodic table. First up, element and atom are very similar words. Element is kind of describing it, whereas atom is the physical thing, but same difference, really. They are substances that cannot be broken down into smaller pieces and still keep the properties of that element. So, like one atom of gold is the smallest thing that will still be gold. You can find all the atoms that we know about on the periodic table, which I'm going to give you one in class. But let's stop and have a quick look at one here. In each of these boxes, they sort of rounded boxes, you'll see a symbol. A helium is He. You'll see its name. You'll see a number that's just a single number and then a decimal number. They are organized this way for a reason. I know the table looks a little weird. These ones here, if you notice, it goes from 56 to 72. That's because these two rows down at the bottom would fit in there, but then it would have messed up the whole row, so they just put them down there. By the way, if you need a periodic table and you go in Google Images and just search periodic table, that'll be fine for biology because all the ones we use are up here and over here on the top. Those have been the same since forever. The ones down at the bottom might be different depending on if you look at an older periodic table, but it doesn't really matter that much for us. So what's in an atom? Atoms have three parts. There's protons, neutrons, and electrons. The protons and neutrons are in the middle. The electrons are around the outside. We're going to see more about each of them. The number of protons identifies the atom. So every atom has a specific number of protons. That's the positive charged ones. No other atom is going to have that same number. The atomic number tells you how many protons you have. In those boxes on the periodic table, there is a single number, like we just said. That's your number of protons. That atom will always have that number of protons. So if I back up here to this, hydrogen will always have one proton. Helium will always have two protons. Lithium is 3, beryllium 4, boron 5, carbon 6, nitrogen 7, how's this going? Whatever this single number is inside the boxes, that's always how many protons they have. Carbon is one that's real important for biology. It always has 6 protons. If it lost a proton, then it's not carbon anymore. Now it's boron. If it suddenly gained a proton, well, now it's nitrogen. See what I mean? We use protons to identify which atom it is. The electrons are used for bonding. My cat says hello. Some atoms want to bond with others to create molecules. Some atoms don't want to bond at all. Some of them want to bond a lot. Some are in the middle. They can or they can't. They don't really care. When you see pictures like these, all these dots are supposed to be electrons. This is a carbon atom, carbon C, O, oxygen. Okay, we're going to get to neutrons. I just wanted to check and make sure I had neutrons somewhere in here. Covalent bonds are between two things that are not metal, and covalent bonds share electrons. Ionic bonds are between a metal and a not a metal, and in that case, one takes the electron from the other. Metallic bonds are a thing, but for biology, they're not really important, so I'm just ignoring them right now. And hydrogen bonds are one that is going to come back. It's between hydrogen and another atom. So covalent and ionic are super strong and very hard to break apart. Hydrogen bonds break all the time, but they're still important. Hydrogen bonds are how water does things. Hydrogen bonds are also how DNA is held together. They're still super important. They're just not as strong. So let's back up here. You notice it says metals and not metal. How would you know? Well, if you look at a periodic table, it's kind of hard because the colors are almost the same. See, like there's this light blue and then dark blue, and there's kind of like a dividing line right here. Yeah, everybody in the top right corner here is not a metal, and hydrogen is not a metal. Literally everything else on there is a metal. So if we had a bond between carbon and oxygen, they're both non-metals, so that would be covalent. If we had salt, sodium is a metal, chlorine is not a metal, so that would be ionic. That's one way you could tell. Covalent bonds will for sure come back. Hydrogen bonds will for sure come back. Ionic might be here and there. We'll see. What about the neutrons? We said protons tell you what the atom is. You can tell by the atomic number. Electrons are used to bond to other atoms. Neutrons add mass. They don't have a charge. Also on the periodic table, in those boxes, you'll see a decimal number. That's its atomic mass. And the reason why it is a decimal number is because it's an average. It's a mean of all of them. So oxygen's is 15.999999999, or sometimes they'll just write 16.0. It's an average of all the different forms of oxygen that could exist on Earth. Let's look back at the periodic table one more time. So we can see the single number is telling you the number of protons. There's the symbol, there's the name, here's the mass. It's the number of neutrons plus protons, actually. For the ones that are on top, usually the atomic number and the mass are pretty much like doubled. You know, see like 8 and 16, 7 and 14. So once you get down here, that gets weird, but we don't need those for biology anyway. Last thing, there are 6 important atoms. We're going to get out a periodic table and highlight them. They're that important. You don't have to worry about the other 180 whatever there are. Just these 6. It's all you need for biology. Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. Chomps. Remember chomps. Or sponge is another one. Anyways, hydrogen and oxygen is water. Carbon, hydrogen, oxygen is carbohydrates and the fats. If you add in nitrogen and phosphorus, that's DNA. If you add in all of these, then those are the proteins. So that's all the molecules that are important. If you can remember those 6, you're good. Chomps. Got it? There is no secret word today, but thank you for listening. Maybe there'll be one next time. So make sure you're always listening to the notes and following along. We'll see you next time.